Red dwarfs. Red dwarfs are just suns in their main sequence. They are just doing the thermonuclear synthesis. They are just doing the stellar nuclear synthesis, the thermonuclear reactions. Inside of them, it is warm and hot because the pressure is pressing together, and the two hydrogen are overcoming, because they're so hot, their electrostatic repulsion. They're sticking together, forming helium. Red dwarfs are much smaller, and therefore this gravitational pressure, which makes the heat in them and so on, is much smaller, and this happens much slower. Therefore, they are not so bright. They have less luminosity, they have less mass, therefore less gravity, and also a smaller diameter. So they're much smaller, less bright. Inside of them, this stellar nuclear synthesis, two hydrogen pressing together to become helium, is not happening so fast. And another reason is the heat rises up and then cools down and it goes down again. So the hydrogen from the outside is also used up. In a bigger star, where the hydrogen at the outside is almost never used. It's just in the center at one time all used up. When it goes a bit together, and when it goes together, some hydrogen is, because the gravity is still so strong, but in the middle is now, the thermonuclear synthesis is no longer happening, because there's no hydrogen anymore used up, and it goes together. And there's no pressure to the outside through this stellar nuclear synthesis, and it collapses basically. When it collapses, some hydrogen comes again into the center, enough pressure, new one, it expands and so on. But basically, most hydrogen is never used up in bigger stars. Red dwarfs use it all up. The heat goes up and cools down and sinks again down, and the hydrogen, basically the whole thing is churned through completely, and all the hydrogen of a red dwarf is used up. And that makes it that such a red dwarf, for example, Proxima Centauri, lives 1,000 times as long as the Sun, which is 300 times as long as the universe is existing. A trillion years, what would it be? Now, so red dwarfs, there that happens much slower because they have much less pressure. And they are not so bright. Proxima Centauri is the closest one to the Earth. It cannot be seen with the naked eye. It is 100 times too faint to be seen with the naked eye from Earth. 80% of stars out there are red dwarfs, or 80% of the stars closest to the Sun are red dwarfs. And no one can be seen because we're too faint. Because inside of them the pressure is too low, because we're too small, the hydrogen is pressing not so fast together, not so much luminosity. That is according to Mark A. Garlick's Cosmic Planetary book on page 40 and 41.